In classwork 4, we will be discussing how to describe a function. Now, when you describe a function, the first thing you want to do is sketch it, and just to get an idea of what it looks like. From there, we can identify its domain. Hold off on the range until you find any absolute max or mins. That'll help you find the range. So from there, we're going to determine if we have absolute maximums and minimums, which means it is absolutely the highest point or absolutely the lowest point on your function. Or if we have relative, and we can have both, relative mins and maxes. Once we identify those, we can see where it's increasing or decreasing. A reminder on these increasing, decreasing sections that you're looking as y to increase or decrease, but you are tracking the x values. Think of a roller coaster where it goes up and down, where you increase, then you decrease, then you increase, then you decrease, and all along this is over your x. From there, we will look at your intercepts. Your x and your y intercept allow you to find a little bit closer to your sketch to be able to define it. Odds and evens, if it's even, it will have symmetry with respect to your y-axis. It will follow your rule of a reflection, where xy will go to negative x, y. If we don't have even, we check for odd. Odd is a reflection through the origin. It follows your reflection rule of xy is going to go to negative x, negative y. And if it doesn't have either one of these, then it is simply neither. So let's go take a look at one. For our first function, you're going to put in your y equals negative x squared plus x. You will get a sketch that looks very similar to this. If it is difficult to see exactly where it comes over the x-axis, you can always change your window setting. Don't use the zoom, change the window. Define it. Do x and y minimums and max. Put your x min and your y mins at -2, and put your x max and your y max at 2. That'll help you define your window, and you can see that area a little bit better. We can tell by this function that we have a domain of all real numbers. We cannot yet tell where that y is. So we look over and we notice we have an absolute maximum, and we're going to label this point A. Right there. And we're going to take our calculators, and we're going to go second calc to number 4, maximum. And you're going to identify your maximum. It should come out to be 0.5, 0.25, or 1/2, 1/4. I like to put this one on my graph because it helps with the increasing, decreasing. Now we can go back and do the range. The highest point on the y is going to be your 0.25. It's coming from negative infinity to 0.25. Okay, so that identifies your range. We can look at your increasing. It increases this way from negative infinity of the x, and it's going to stop at the 0.5. Now, increasing, decreasing will always have soft parentheses. We then look this way, and we notice that's where it's decreasing, while the x is 0.5 to infinity. Our x and y intercepts are very important to us. We will first find the x-intercept. Now, even though you can spot it on your graph, or you can spot it in your table, we still have to follow these algebraically. An x-intercept will mean we have a 0 for the y. So we're going to replace the y with a 0, and we're going to take our function and factor it. So we're going to factor out an x. we're going to set these both to 0. This is why we spend so much time on that factoring. And negative x plus 1 equals 0. So x is going to be equal to 1. So we have 2 points, 0, 0, and 1, 0. So we're going to label this B and C. It's easier to label the points on your graph and keep the coordinates in a different place here so that it doesn't get too crowded up by your graph. So now we're going to find your y-intercept. This one's the easy one. This is when x is at 0. Even though you can tell that it's going to be your 0, 0, you still have to solve it algebraically. So we put in a 0 for the x, and we can tell that our y is 0. And we have this already labeled for us as B. The last step is the odd or even. We're going to take this and replace it with a negative x. Keep that negative outside. Put the negative x in for x. So this becomes negative x squared minus x. This is not the same as the original, so this is not even. So we're going to factor out a negative 1, and we're going to check if it's odd. This is not the same, so therefore this is neither. And you can tell by looking at the graph that it does not have symmetry over the y-axis, nor does it have symmetry through the origin. The next function that we're going to do is a cubing function. And this has a few little things going on in it, but I thought it was important to show you one that doesn't work out too smoothly. So we're going to graph this guy first. You can put him in your calculator. Make a sketch. It's cubing. Notice the 3 in the exponent means it has 3 roots, 3 places that it crosses the x-axis. And 3 minus 1 will give you 2 turning points. So we can tell by the domain that this is all real numbers. And we can tell the range, this is all real numbers. We look at the absolute maximums and minimums and we say, this does not have an absolute max. This guy for the maximum keeps going up and up. This guy for the minimum keeps going down. So we can cross out the absolute and we can look for a relative max and a relative min. So we're going to call this point A for our relative maximum, and we're going to call this point B for our relative minimum. Now you're going to do this on your calculator. Remember, second calc, number 4 for maximum, number 3 for minimum. Remember to isolate that maximum and then hit the guess. Isolate the minimum and hit the guess. You should come out with a relative maximum of 0, 2, and you can see that on your graph as well, and a relative min of 2, negative 2. From here, we're going to put this up here so that we can figure out our increasing and decreasing. Again, this is like a roller coaster. So we start increasing right here, and we stop when we hit A. So we increase from negative infinity to 0. Remember, we're tracking the x values, but when y is increasing. From A to B, notice we are decreasing. So we are decreasing from the x value of 0 to the x value of 2. From B to the right, we are increasing. So we're going to add another section for our increasing from 2 to infinity. At this point, you can look at your increasing and decreasing and realize it goes from negative infinity to 0, then 0 to 2, then 2 to infinity. It covers your entire range. To find your intercepts, we'll do your x-intercept first. We're going to set y is equal to 0. So we're going to put it in your 0, and this is a cubing function. And because you really don't know how to do a cubing factoring yet, I'm going to give you the factors. And x minus 1 and x squared minus 2x minus 2. We set these both equal to 0. we can readily see this one here. We're going to call this guy C. This one, the second one, when we set to 0, is not factorable. So when something is not factorable, we have to use the quadratic equation. This happens. That means the point at D and E are irrational. And you can tell that in your calculator by doing a second calc zeros. Isolate them and check them against what you get as a result for your quadratic formula. So you'll go ahead and do the quadratic, and I will be so kind to give you the roots. So these are our roots. So we have 1 plus radical 3, 0, and we have 1 minus radical 3, 0. From here, we're going to do your y-intercept. Your y-intercept, remember, is easy. That's when x is equal to 0. And yes, you can see it on your graph, but you still have to solve it algebraically. So we're going to put your zeros in. So we have 0 cubed minus 3, 0 squared, plus 2. This will give us a y of 2. And our 0, 2 is what we had as our relative maximum. Then we're going to check to see if it's odd or even. We're going to replace the x with the negative x. And we're going to get negative x cubed minus 3 times negative x squared plus 2. This will give us negative x cubed minus 3x squared plus 2. This does not match our original, so it is not even. We're going to factor out a negative 1, causing the second one to become positive and the third one to become negative. If this guy matches the original, then we're odd, which it doesn't. So in this case, we are neither. We're neither. And that's your graph.